Hello, dreamers. Welcome back to Bedtime Universe. Lay your head down, breathe slowly, and let the room around you dissolve into a soft, velvety hush. Tonight I will tell you not one quiet tale, but many threads of human curiosity and cosmic mystery braided together like a slow, luminous rope that pulls us out beyond our familiar shore. These are stories that have traveled, in some form, from watchful telescopes and busy laboratories, from deserts, where astronauts learn to listen to the wind, from the clever hands of students sketching life support systems on napkins, and from the deep, patient light of newborn worlds. Each thread is a small miracle. Each breath you take now travels the same physics that carry starlight. Let us begin. Imagine a field of dust that is almost too fine to notice, a gossamer of grains smaller than a fingernail, circling a young star. For eons, the dust whirls in slow, patient currents, colliding, sticking, growing. Sometimes those grains gather into pebbles, then into rocks, then into something with gravity, with a faint warmth, with a tiny, greedy appetite for more. In the glow of distant instruments, we have not just imagined, but watched this process in motion. Recently, the human eye in space, the James Webb Space Telescope, trained its golden gaze on a massive planet, encircled by a disk of dust and gas, and found evidence that within that ring, the raw chemistry to build moons is present. It is the very stuff of small worlds, hydrocarbons and carbon dioxide, the whisper of molecules that, over cosmic time, might clump and spin into moons of ice and rock. We are watching, in a way that would have seemed magical to earlier generations, a construction site for moons around a faraway planet named CT-CHAR-B, some 625 light-years from our own sea of blue and green. Now let that image fold into another. Picture a planet so recently formed that it still glows with the heat of its own birth. Imagine light wrapped around it like a shawl, a fragile violet halo in the cold, dark. Astronomers have been lucky enough to capture direct images of such newborn worlds. These are not the distant, cold rocks that circle in silence around our own Sunday. These are infant giants, flecked with warm light, waltzing within the very rings that made them. One of these discoveries was announced with the wonder of a discovery alert. A baby planet photographed in a ring around a star. A minute, hopeful glow that tells us the universe is still busy making itself. The tidings came from careful telescopes and patient analysis, and they remind us that creation is not only in the past. Creation keeps happening, now, elsewhere, as you listen to this story. From the quiet work of the universe, we return our gaze, gently, to the busy, tender work we do for ourselves. In Houston at Johnson Space Center, there are new faces now learning how to be guardians of our ventures beyond the air. A new class of astronaut candidates has been welcomed, 10 in number, each chosen for a life devoted to training, to study, to listening. They learn to move without gravity, to care for each other in small, crucial ways, to swim through simulators that mimic a world with no flaw. They learn wilderness survival, so that, if the unexpected comes, they may adapt with calm and skill. Think of them standing at dusk, tied to suits that smell faintly of rubber and new fabric, watching the same moon you watch from your window. They carry not only their own hopes, but 1,000 small ambitions of engineers who made their rockets lighter, of teachers who once read them stories about the stars, of communities that believe in possibility, and yet, selection alone does not put humans back on the moon. There is a kind of gentle insistence in laboratories and university classrooms everywhere. Teams of learners and dreamers, building things that could one day become lifeways on other worlds. NASA's Human Lander Challenge stands like an open door. It invites students and innovators to propose life support systems, to imagine how a group of people might live and breathe and sleep in a place that has no atmosphere to hold them. The call is practical, and it is poetic. It says, "Help us build homes of air and warmth for people who have not yet set foot on the lunar dust." It asks for pipes and filters, for ways to manage heat and the cold, to scrub carbon and carry water where there was none. It is a challenge and an invitation to stitch human ingenuity into the cloth of exploration. The design sketches and late-night cups of coffee that form in response are as much a part of human exploration as rockets and telescopes. Now, allow the story to drift a little further outward until the dark is not empty, but full of steady points of light, each a story. The James Webb Space Telescope has been mapping more than single planets and disks. It has turned its instruments toward great nurseries of stars, places where clouds of gas and dust coalesce under gravity's patient pull to ignite the first clear flame of a new star. In a region called Pismis 24, Webb has taken a sparkling image of star birth, a tapestry of orange and near-infrared light that shows clumps of matter arranging themselves into tomorrow's suns. Each such image is an atlas of origin, a quiet ledger of the ways matter organizes and becomes luminous, a reminder that even violent births can be beautiful. The telescope's images are not just pretty pictures to hang in a gallery. They are evidence, data, that allow scientists to ask how galaxies are built, how thick stellar disks form, how environments shape evolution. In these portraits of birth, we can almost hear the slow exhale of the universe as new heat begins to beat. The human stories loop back and forth with these cosmic events. Students building lander prototypes imagine future astronauts walking across regolith stirred by engine plumes. Engineers who study particle physics design shielding to keep that astronaut's heart beating steady against invisible rain. Flights take to our own atmosphere to measure the air we breathe, with scientific instruments tucked into aircraft to sample tiny particles and trace gases. The same curiosity that has us peering at newborn planets also leads us to measure the breath around our cities and the flow of water after a fire. The data that orbiting satellites send down help protect the people on a hillside downstream from a burned watershed. Science is a conversation between distant glories and immediate care between the stars and the soil. Imagine a lab at night, the lights low, screens glowing like constellations. A team of scientists studies spectral lines, thin patterns of light that reveal the chemistry of a planet-forming disk. The patterns tell of hydrocarbons and simple organics, the building blocks of complexity. Elsewhere, a group of students assembles a prototype for transferring fluid without losing heat. A little farther on, an astronaut in training slides out of a simulator and rubs her hands together, thinking not of the instruments she will one day use, but of the person who will rely on her care in the small hours of an alien night. The tether that binds these moments is responsibility. Each discovery is met with the question, how do we make this knowledge useful? How do we keep people safe while they explore? Let us drift now past formalities and into a simpler human moment. Picture a child somewhere on Earth, wrapped in a blanket and gazing at a tiny LED projector on the ceiling that shows slow, twinkling stars. Perhaps she has heard of the Webb telescope's images. Perhaps she has read a small headline about a planet being photographed in a ring around a star. In that child's small mind, the universe becomes an immediate companion, a place of friends waiting to be met. That is the true power of what we do when we send telescopes into the dark. We give the next generation an expanded map of what is possible. You might imagine that space agencies and large telescopes are remote, their work cold and technical. But the truth is softer and stranger. It is a story of many hands, of late-night code that finally runs, of metal surfaces polished by apprentices, of teachers who press a paper telescope into the hands of a child. When Webb returned images of star formation, people anywhere with an internet connection could pull those images like a blanket over their lap and study them. The images cause wonder precisely because they connect the very small with the very large, the grain of dust to the gleam of a newborn Sunday. Think now about silence in space, where sound cannot travel the way it does on Earth. In the quiet between stars, telescopes listen in other ways. They read the fingerprints of light. They read shadows and cooling curves and the faint warmth of gas. The story of CT-Char b and its moon-forming disk was written in such fingerprints. It required patient observation and careful analysis. It is also a story that tells us something about the potential for complexity in other systems. It says that the processes that once formed our moon, or shaped our planet, are not unique. Elsewhere, in a dark ring around a young planet, dust and molecules dance out the recipe for new satellites, miniature stages where future geology and perhaps future chemistry will play out. Our world, meanwhile, keeps asking to be protected. NASA's instruments that roam the skies help scientists map how fires alter water supplies, how dust moves after an engine plume, how particles travel through our air. That knowledge helps a farmer know when to plant, helps a town understand the safety of its reservoirs, helps an emergency team decide where to put sandbags. The same curiosity that reads starlight becomes a tool of care on Earth. Now allow the narrative to fold in one more theme, the idea of apprenticeship and challenge. Challenges like the Human Lander Challenge are not only contests, they are classrooms with very public finals. They ask people to imagine the improbable and then make it real enough to test, to prototype, to fail, and to learn. Think of student teams whose hands are inked with schematics and whose whiteboards are full of scribbled equations. They are the ones who will iterate through failure to find something that works in the harsh vacuum and abrasive dust of the moon. Prizes and challenges push ideas forward, not by fiat but by curiosity. As your breathing slows, imagine a single small scene that gathers all these threads into one gentle image. A young engineer sits before a screen displaying a glowing ring around a planet. On his desk is a plastic model of a lander. On the shelf, a faded photograph of the Grand Canyon. Beside him is a calendar with the dates of a student challenge he hopes to enter. Outside the window, a plane traces invisible ribbons in the sky as it samples the atmosphere. He thinks, quietly, of the future, of a person who will one day sleep under a thin dome on the moon, who will look up, not at clouds, but at a sky filled with Earth, and who will know that someone in a dusty lab once dreamed and sketched and kept going. He knows his work is small and essential. Stories like these are not all triumph. They are also full of patience and slow correction. Telescopes can mislead, and data can be ambiguous. Plans can be refined. What matters is the persistence of the people who care enough to examine the difficult parts and take the time to get them right. It is the same persistence that lets a child return to a puzzle until she understands it. It is the same quiet stubbornness that has led humans from carved stone to spacefaring craft. And now, for a last little voyage before sleep takes you. Imagine that the very dust that built those newborn planets someday seeded life elsewhere. Imagine also that our own small planet continues to require tending. The researchers who measure our air, the students writing code to manage life support, the dreamers drafting lander designs, the astronomers pointing Webb at a distant nursery. All are involved in a single, long labor of stewardship. The universe offers wonders without end. Our job is to learn how to reach them and how to live wisely beneath their glow. As your eyelids grow heavier, let the images settle like a soft film behind your eyes. See the golden honeycomb mirror of a great telescope, its facets catching faint infrared light. See the slow ring of dust around a distant planet, curled like a sleeping animal. See the new astronaut stepping out of a training pool, smiling at the absurdity and joy of it all. Hear, faintly, the hum of aeroplanes that check our air. Feel the gentle insistence of students and their challenges. Take one more long breath in now, and let it be full of stars and the cool chemistry of distant disks. Breathe out, releasing everything you have carried from the day. Lay your cares upon the pillow, and know for a quiet moment that human curiosity and careful tending continue all night and all day. People at observatories and centers of learning are awake in a different time zone, poring over small signals and long data sets. They will snooze, and they will wake, and they will continue the work that expands what we can imagine. Sleep now, explorer. Dream of moons being born in the lullabies of dust and light. Dream of engineers whose sketches become habitats. Dream of young astronauts who will one day float by a window that looks down on a sleeping Earth. When your eyes open again, the world will have spun a little further in its orbit, and perhaps a new image will have arrived to remind us that the cosmos is never finished telling its stories. Good night, from all of us here at Bedtime Universe. All right, the next story we settle into is about deep time, the faint hum of cosmic interconnection, and a mystery that only began to unfold when everything in the outer solar system aligned in a way no physicist thought possible. This is the tale of Project Lachesis, and the unsettling whispers carried on the solar wind during the solstice of Eridanus. Part 1. The arrival of the rogue shepherd. In the cold, perpetual darkness that lies beyond the Kuiper Belt, past the final, lonely sentinels of ice and rock, a celestial body was moving. It wasn't a comet, pulled by the sun's fierce gravity. It wasn't a Kuiper Belt object, tethered to the ecliptic plane. It was an object catalogued as Xylos, a rogue exoplanet, roughly the mass of Mars, traveling on an impossibly shallow hyperbolic trajectory that was bringing it into our Oort cloud, yet not towards our Sunday. Imagine the Oort cloud, that vast spherical shell of icy debris as the very edge of our sun's dominion, a shimmering, silent boundary between the known and the interstellar void. For millennia, it has remained undisturbed, a frozen record of the solar system's birth. But Xylos, this quiet, dense traveler, was slicing through it like a ghost ship through heavy mist. The scientists at Project Lachesis, operating out of a subterranean complex in the Atacama, initially dismissed it as a statistical anomaly. Xylos was too dense to be a captured object, too distant to be a planet, and its velocity was subtly wrong. It was moving too slowly, yet with an inexplicable rotational frequency. Dr. Elias Thorne, head of the project, often described it to his interns as a silent shepherd, because its passage wasn't causing gravitational chaos. Instead, the distant cometary bodies ahead of it seemed to be settling, their orbits becoming unnaturally orderly, as if drawn into a state of subtle rotational peace. This state of uncanny quietude was the first clue. Gravity, we understand. Chaos, we anticipate. But this induced cosmic order suggested a force that was less about brute mass and more about resonant fields. Xylos was not just moving through space. It was interacting with the fabric of space-time in a way our current models could only vaguely predict, leaving a wake of unnatural stillness in its path. We often forget that space is not empty. It's a plasma-infused medium, a vast electrical conductor, and Xylos seemed to be tuning it. Part 2. The Silence of the Sentinel. Roughly 2 months after Xylos's initial detection, and just as it entered the inner Oort cloud boundary, our attention was wrenched toward the very frontier of interstellar space, Voyager 1. The oldest, loneliest messenger humanity has ever launched, now traveling through the turbulent, magnetically active realm of the interstellar medium. For decades, Voyager's plasma wave subsystem had been sending back a steady, albeit faint, recording of the density and magnetic pressure outside the sun's influence. It was the sound of space, a low, oscillating hum. Then, at 3:17 UTC on the morning of the solstice, The hum stopped. Not a sudden catastrophic failure, which would have indicated a micrometeorite strike or power loss. Instead, the data stream showed a perfect, complex harmonic spike, a signature so mathematically pure, it initially triggered a data corruption warning. The spike lasted exactly 4.83 seconds, and then the plasma wave detector went dead. Silence. A digital void that stretched for 3 hours before the system miraculously rebooted, only to report normal but inexplicably weakened background noise. Dr. Thorne, a man who rarely used adjectives stronger than noteworthy, called the initial 4.83-second burst a signature of deliberate compression. The energy was not random. It was structured, like a perfect chord struck on a gigantic interstellar string. It suggested that a colossal wave of structured energy, perhaps an extremely low-frequency electromagnetic pulse, had washed over the probe. A wave that carried a pattern, not noise. What was the common thread? Xylos was still hundreds of billions of kilometers away from Voyager, yet the moment of the signal's emission was calculated to have perfectly intersected with the time Xylos crossed a major heliopause boundary relative to the plane of the ecliptic. It was a conjunction of events separated by unimaginable distances, yet connected by a single, terrifying timestamp. Part 3. The geometric veil of Saturn. The third, and perhaps most beautiful piece of the puzzle, appeared orbiting the ringed jewel of the solar system, Saturn. Saturn's rings are a masterpiece of chaos and gravity, billions of particles of ice and dust, constantly colliding, shaped by the push and pull of its many moons. The ring system is dynamic, complex, and utterly predictable under the laws of physics. However, a global amateur astronomy collective, monitoring Saturn's rings for the annual Mimas resonance shift, captured something unprecedented. A new, perfectly defined, faint K-ring had formed in the outer F-ring zone. This ring was not a cloud of particles, it was a structure. It possessed a lattice-like geometry that was visible only under specific infrared spectrums, forming a series of non-Keplerian shapes, squares, tetrahedrons, and perfect hexagons that rotated not by gravitational rules, but by an internal, synchronous frequency. The material forming the K-ring was not typical water ice. Spectroscopic analysis suggested charged silicates infused with rare earth plasma, and its formation was instantaneous, not gradual. It appeared overnight, on the very day the Voyager signal went silent. This geometric construction, defying the mathematics of orbit mechanics, suggested an active manipulation of the magnetic field lines. Saturn is a giant magnetic dynamo. Its rings are essentially vast plasma screens. The K-ring was acting like a colossal circuit board, holding impossible shapes in place through an unseen electromagnetic framework. Thorne theorized it was a triangulation point. The rogue planet Xylos, the charged particle field of the Oort cloud, and the magnetic field of Saturn were not three separate entities. They were nodes in an ancient, forgotten network. Part 4. The inevitable alignment. The ultimate realization lay in the calendar. The solstice of Eridanus. This wasn't a modern alignment. It was an ancient, calculated celestial moment when the center of the Milky Way galaxy, the plane of the solar system, and the most distant star in the Eridanus constellation that the ancients could track, all fell into a near-perfect 33.3-degree angle. This particular angle, according to obscure astronomical texts recovered from a forgotten observatory in the Himalayas, was called the angle of zero entropy, the point where the flow of cosmic energy achieves maximum coherence. Every event that had transpired, the calming field around Xylos, the perfect harmonic spike from Voyager, and the geometric formation of Saturn's K-ring, had been timed not to the modern Julian date, but to this ancient, almost mythic solstice. The hypothesis. What if the solar system, with its planets, its magnetic fields, and its plasma sheaths, was not merely a mechanical clockwork, but a vast organic resonating instrument? And what if Xylos wasn't a rogue planet, but a key, a massive, natural tuning fork, designed to enter a specific region of the Oort cloud at a specific time, to induce a coherent magnetic field resonance that would travel through the interstellar medium, strike the Voyager probe at the perfect instant, and finally, activate the solar system's primary magnetic node Saturn to display a geometric signal. The signal wasn't a radio transmission. It wasn't a light pulse. It was a structure. A temporary, perfect architectural arrangement in the plasma of the rings. A message written in the language of pure physics and geometry, lasting only a few weeks until the solstice alignment broke. The whispers carried by the solar wind were not random. They were the gentle hum of this cosmic mechanism coming to life after eons of silence. Epilogue. The deep hum of connection as we watch the solstice pass and the K-ring slowly dissolves back into the random chaos of Saturn's dust. We are left not with answers, but with a profound sense of awe. The events suggest a vast interconnected ecology of energy, where the movements of a single rogue body can ripple across light years and awaken ancient dormant physics. It forces us to reconsider what coincidence truly means in a universe defined by laws we have barely begun to scratch the surface of. Perhaps the greatest lesson from Xylos, Voyager, and Saturn's geometric veil is this: we are not observers in a cold, silent universe. We are living within a massive, intricately wired machine that occasionally, gently, and with infinite patience, sends us a message written in the language of stars and magnetic fields. Rest now. Let your mind drift with the slow, resonant currents of the cosmos. The universe is awake, and its humming is the softest lullaby. Good night. Okay, let's go to the next story. Close your eyes if you like, or keep them softly open. Let them fall into the gentle half-light, where room and sky breathe together. Breathe once, slowly, as if inhaling a secret the universe has been whispering for billions of years. Breathe out. Release the day, like a small stone dropped into a wide, patient pond. Tonight we will walk, softly and carefully, along the edges of wonder. Imagine first a single point of light, far beyond the reach of your fingertips. It hangs in the vast blue-black, a patient ember in the dark. That light is an ancient letter, written in photons and carried for eons across loneliness and time. Each photon is a tiny messenger telling a story of clouds collapsing, of pressure building, of eventual fire. It tells us how a star was born. We begin in a nursery, not of cradles and lullabies, but of dust and quiet gravity. In these vast stellar nurseries, clouds of hydrogen breathe and sigh. They swirl and settle, a slow, graceful choreography. Regions within them grow heavier, tiny seeds of density that call to each other. Gravity, subtle and relentless, draws them closer until warmth blooms in the heart of a contracting cloud. At first, there is only the hush of atoms colliding, but then the hush becomes a murmur, and the murmur a steady hum, the birth heartbeat of a star. Picture that newborn star like a candle cupped against a blizzard, fragile yet defiant. It begins its long work of turning matter into light, forging heavier elements in its crucible. Over millions or billions of years, it is both creator and instrument. Carbon, nitrogen, oxygen. These are not gifts dropped from nowhere. They are the labor of stars, the slow alchemy that stitched the periodic table into patterns that would one day be read by biology. Drift now to the patient geometry of planets. The protoplanetary disk that surrounds a young star is a slow-turning carousel. Dust grains stick like shy dancers, finding partners. Pebbles accumulate to rocks, rocks to boulders, and boulders, by a kind of stubborn fortune, become worlds. Each planet falls into its lane, some near and scorched, others distant, wrapped in the deep sleep of frozen gases. Some catch thick atmospheres and wear them like robes. Others are bare, their scarred surfaces reading like old maps. Listen. The language of geology speaks in storms and tides, in continents wandering on oceans of rock, in the patient corrosion of winds. On some worlds, water pools and waits rivers tracing the skin of the planet, oceans breathing with the slow rhythm of tides. Where chemistry and liquid meet, curiosity becomes possible. Where energy is steady and ingredients meet for long enough, chemistry can begin to take the first timid steps toward biology. Life, when it appears, is not an announcement so much as a very quiet persistence. It is the universe learning to know itself through rearranged atoms and the improbable poetry of replication. Let your mind stroll now beyond the pale neighborhood of a single star to the wider assemblies, binary stars that spin around each other in an intimate conversation. Systems where planets chase one another in complex arcs, moons that steal the stage and then return it. Imagine a night sky from the surface of a world that circles two suns. Dawn here and dusk there, shadows overlaying and unraveling, as if the universe were practicing a gentle illusion. Or imagine a planet where the seasons stretch for centuries, and an entire civilization learns patience from a slow, wandering orbit. We can come closer, closer than even the crescent of a moon, and meet comets. Comets are wayfarers, icy, ancient, carrying the scent of the outer reaches. When they approach a star, heat teases their frozen past into jets of dust and gas, creating a tale that points away, like a memory streaming behind a moving soul. Some comets have visited the young Earth, delivering water and organic molecules, small serendipitous couriers, possibly responsible for nudging chemistry toward life. They are reminders of how the universe keeps its treasures in remote vaults until the right moment. Now, allow the scene to widen. The galaxy is not a static painting, but a slow, turning ocean of stars. Our Milky Way is a disk of countless lights, an elegant swirl observed edge-on as a delicate line of soft brightness, or seen from within as a band of spilled sugar across the night. The galaxy's spirals are arms roots of ongoing formation, places where gas is funneled, compressed, and nudged into new generations of stars. At the center sits a quiet storm, a supermassive black hole, not a hungry villain in a storybook sense, but a sculptor whose gravity molds the dance of millions of suns. Black holes are not only endings, they are thresholds. Their gravity warps both space and time, bowing light as if the fabric of reality were a soft sheet. When a black hole feeds, it can make light brighter than entire galaxies, an irony that reminds us how extremes are sometimes necessary to create beauty. Around many black holes, matter swirls in a furious incandescent maelstrom, jets of particles leaping outward like fountains that pierce the dark. The mathematics that describe such objects are both austere and wondrous, a vocabulary where infinity and smallness meet. Think for a moment about the scales we talk about. Atoms to planets, planets to galaxies, galaxies to clusters, and then to the cosmic web. Between galaxy clusters, filaments of gas and dark matter trace a pattern like frost on a window. Dark matter, an invisible presence, holds the web taut, a scaffolding without which galaxies would not gather. Though we cannot see it with our eyes, we sense its gravity by watching things move as if pulled by invisible hands. There is humility in that. Much of what shapes the universe is one step removed from our senses, and yet is no less real. Time itself carries a story. The cosmic microwave background is a faint afterglow of the universe's earliest visible chapter, a whisper from when the universe was just a few 100,000 years old. It is cool now, a mere 2.7 degrees above absolute zero, but it is a map, a photograph of the infant cosmos, with tiny fluctuations that seeded everything that followed. To hold that image in your mind is to understand that even the largest things started as the smallest differences, tiniest ripples that eventually grew into vast structures. Picture the cosmic timeline like an old patient book. The first pages are quick and feverish. Inflation, a sudden stretching that smoothed space like kneading dough. Then, atoms formed, light untangled from matter, and a dark age fell long and silent until the first stars lit tiny lamps that pushed back the gloom. Galaxies assembled, merged, and spun off new generations of stars. Planets formed from the debris left in the aftermath of these cosmic negotiations. In this unfolding, humanity appears very late, an afterthought in the second-to-last paragraph. And yet, in the human mind, a universe of meaning ignites. Let us visit one small chapter in which curiosity itself evolves. Consciousness. Somewhere in the long history of Earth, early cells invented a trick replication with variation. And then, over eons, nervous systems learned to sense. Brains are storytellers. They knit signals into patterns and name them. Consciousness is an emergent candle, lit by complexity, sustained by exchange, and flickering with memory. It is in this candlelight that we ask why and how, and in asking, we create narratives that fold the cosmos back onto itself. Imagine now an observer standing at the edge of a cliff beneath a trembling aurora, or a night watchman on a ship gazing at the stars smeared with meteor trails. The same processes that cook the insides of stars also create the copper in your phone camera, the oxygen in your lungs, the metal in a bridge, the calcium in a tooth. These are all descendants of ancient stellar furnaces. There is a soft, almost ineffable intimacy in that. The universe gave us, over long patience, the very elements that make selfhood possible. We can also sense the fragility of home. A planet's atmosphere is a delicate blanket. It can warm gently under a benevolent star and sustain richness, or it can be stripped away by flares and winds, leaving raw stone. Small differences in chemistry, rotation, or magnetic shields can mean the difference between a world teeming with potential and one that remains mute and barren. The history of planets is a study in chance and contingency. Local weather, global catastrophes, rare impacts, the ephemeral vicissitudes that shape long-term trajectories. Turn your attention now to communication across distances. Light is a faithful courier, but it travels at an upper limit. Signals sent across interstellar space take years, centuries, or millennia to arrive. Even at light speed, messages are delayed by the tyranny of scale. If someone on a planet 500 light-years away shouts into the dark, their voice is a letter that will arrive here only 5 centuries from now. That slowness teaches humility and patience to any mind that imagines sending greetings. Consider how we listen. Our instruments extend senses. Radio telescopes tune to the faint hum of hydrogen between galaxies. Spectrometers unweave starlight into colors and reveal composition like detectives reading fingerprints. When we find a spectrum with telltale signatures, water, methane, oxygen, we do a kind of forensic archaeology across time and space. We cannot visit many of these places. Instead, we learn to translate the light they send, to read whispers of chemistry and motion, and to infer landscapes from small, indirect clues. There is also the poetry of scale in motion. Galaxies collide not as catastrophic bangs, but as slow, majestic ballets that stretch across millions of years. When two galaxies meet, their stars mostly pass like ghosts, but their gas clouds crash and ignite bursts of star formation, new lights born from the turbulence. In the far future, our Milky Way will kiss Andromeda in such a dance, a slow merging that will change the map of the night, but will not necessarily be an apocalypse for individual systems. Time grants the universe a kind of patience we cannot fully fathom. Let us touch, briefly, on endings and beginnings folded into one. Stars of certain masses end their lives with a final flourish. They swell into red giants and drop outer shells that smell of future gardens, planetary nebulae, whose glowing rings are nothing less than stellar farewell notes. Some massive stars go out as supernovae. They explode with a brightness that can outshine entire galaxies for a while, scattering heavy elements into the void. These explosions are fertile. They pepper the interstellar medium with the seeds for future planets and life. The iron in your blood was once inside a star that died in fire. And then there are rarer endpoints. Neutron stars compacted into the mass of the Sun, but squeezed into a city-sized sphere. Spinning so fast, they sweep beams of radiation across space, like distant lighthouses. When two neutron stars merge, they ring the cosmos in gravitational waves, ripples in space-time itself. These ripples are like the faint tremors of a gigantic bell, small on our scales but monumental on a cosmic ledger. We have learned to hear them, to listen to space-time, and in doing so, we have opened a new sense. Now imagine, for a slow moment, a distant sea, where bioluminescent organisms light up like stars in miniature. Each little flash a private signal, an invitation, a memory. On some exoplanets, life, if present, might glow under active skies, or it could be hidden within subsurface oceans under a frozen crust. Moons like Europa or Enceladus, in our own system, hide oceans beneath icy shells. There is something deeply consoling about water kept warm and dark for aeons, about the patient possibility contained in enclosed seas. If life exists elsewhere, perhaps it is quiet, tucked into corners where chemistry can be steady and undisturbed. Let your thoughts wander to civilizations, which may exist as brief candle flares along a long timeline. The technological curve of a species could rise quickly and fade due to self-made or natural disasters. It could also plateau into a sustainable, quiet stewardship. We do not know. We only know our own species' late curiosity and the sudden brightness of our signals leaking into space like dandelion seeds in a wind. Radio and light-based signals expand outward, thin and faint, like footprints in powder snow, detectable at a distance if someone is both listening and clever enough. There is comfort here too. Loneliness on cosmic scales does not mean emptiness. The cosmos is full of patient processes. Life and intelligence, if rare, may be spread like scattered campfires across an enormous plain. And perhaps the act of knowing, of looking, measuring, imagining, binds us into a community with the rest of the cosmos. In studying stars and particles, in parsing spectra, and building telescopes, we cast ourselves as students in a grand school. As you listen, either with your ears or with your mind, feel the rhythm of the universe as a lullaby of durations. A human lifetime is a handful of breaths compared to geological ages, and geological ages are a blink beside cosmic epochs. Yet within a single heartbeat, we can hold awe, grief, curiosity, and love. These human scales are not failures of perspective. They are the universe experiencing itself in a compact, fervent form. Now, imagine returning home, descending slowly from the bright cathedral of the galaxy, through the still, cold arms of interstellar space, past the commuter belts of comets, past the warm glow of a friendly star. You approach a tiny blue planet, the home you know. From orbit, continents are soft petals and storms curl like calligraphy. Cities are small nodes of light, patterns of habit and story woven together. On one such night, someone looks up with an ancient sort of yearning, recognizing in the dots above both estrangement and kinship. To end, consider this quiet, generous truth. You are made from the same elements as the stars, and those elements have traveled cosmic distances to arrive, patient as rain, into your bones. Your thoughts are shaped by molecules forged in fire. Your curiosity is a continuation, an echo of the processes that stoke stars and fold galaxies. In that sense, the cosmos is not merely something outside, it is an inheritance and a companion. So let tonight be ordinary and extraordinary at once. Let the soft knowledge of distant light settle in like warm dust. If sleep comes, let it be gentle, like the slow drift of an orbit. If your mind wanders, let it wander along the spiral arms, where new stars are still being hatched. Tomorrow, when you open your eyes, the world will feel familiar and newly strange, and you will carry with you the hush of long distances, the patient grammar of the universe, and finally, a closing image. A small child on the threshold of a house, holding a lantern. The child is not yet sure what stories will come, but they are learning to read the sky. The lantern casts a gentle circle of light, and, within it, the child's face is full of person-sized astonishment. Outside that circle unfolds a darkness so wide and generous that it invites stories rather than denies them. Walk now into that small, safe pool of light. Breathe, and let the vastness sing you slowly into rest. Good night. This next story unfolds like a slow river of light, flowing through the galaxy and straight into your imagination. It is not rushed. It does not demand, only offers its calm, like the night sky itself. Begin by picturing yourself under a truly dark sky, no city glow, no neon signs, just you, the quiet earth beneath your back, and above you a pale river of light. That soft ribbon is the plane of our Milky Way, the view from inside our own spiral home. We are looking edge-on through a grand disk of stars, hundreds of billions of them, each one burning in perfect, silent persistence. If the night is clear, you'll notice mottled patches and dim lanes where dust clouds drift, sculpting the light into curtains and folds. That hazy beauty is not far away. It's our neighborhood, our address in the cosmos, and lying beneath it you can almost feel the galaxy breathe. Let your attention rest on a single star. It looks steady to your eye, a silver pin, yet that small light is a sun, with weight and heat and years enough to send you its glow across gulfs so wide they blur into time. The light you see left that sun long ago. It traveled quietly, never hurried, slipping through space until, tonight, it touches you. In this moment, you are reading an ancient postcard. Whatever your day held, messages, tasks, worries, none of them can chase light across years. You are safe here, held inside an old, patient story. Now, soften your gaze. The familiar patterns return: Orion rising in the cool months, Cassiopeia poised like a simple crown, the Big Dipper pouring toward the horizon. We call them constellations, but they're more like gentle chapters in a sky-wide book. Their shapes are not fixed. Over immense spans of time, stars drift with unhurried grace, rewriting the outlines of hunters and queens. The sky, you know, is a snapshot in a long, serene dance. Even change, on these scales, is tranquil. Let's wander inward, between the stars, into the interstellar medium space that is not empty but filled with thin veils of gas and dust. Imagine clouds so vast that a beam of light crosses them for years, and yet so delicate that a teaspoon of air on Earth holds more particles than a kilometer of that cloud. In these gauzy nurseries, gravity does its quiet work, tugging gently, gathering specks into clumps, clumps into knots, knots into hot, shining beads. A star is born not with a shout, but with patient accumulation, one grain, then another, until fire begins and a new light joins the river. Out at the edge of your vision, a blur blooms. The Andromeda Galaxy, our great neighbor. Its glow set out toward us when early humans were first finding their stride. Andromeda is huge, a trillion stars washing together into that single soft smudge. You can stretch out a hand and, with a fingertip, cover an entire island of suns. And in that gesture, you learn something gentle and important. The universe is vast, yes, but it is also reachable to the heart. Even a faint smear of light can carry the weight of millions of worlds and arrive as a whisper that says, "You belong here." Every so often the night sprinkles a brief spark, one thin line, then gone. A meteor is often a grain of dust surrendering to our sky, brushing the air so quickly that it burns, writing a single glowing sentence and fading with perfect timing. We pass through these dusty trails each year, and the heavens answer with showers that arrive like annual lullabies. Perseids, Geminids, Leonids, each with its own subtle rhythm. If you've ever made a wish on a shooting star, you've practiced the oldest astronomy, paying attention and letting wonder open a door inside you. Turn to the moon now, a familiar companion, gentle and constant. Watch its phases flow, a fine silver thread, a letter D, a chalky coin, a lantern strong enough to throw shadows across fields. Its light is sunlight, softened sunlight that has touched dust and old lava plains, bounced back and draped the world with milk. The moon's pull cradles the oceans into tides and, in a way, cradles us too. When its bright face climbs your window, you can almost hear a rhythm, slow as breath, reliable as sleep. And the wanderers' planets write their own calm notes across the sky. Venus glows like a candle held close. Jupiter steadies itself with a kingly brightness. And if you peer through a small telescope, you may see its 4 major moons, little pearls in a line, changing positions night to night in a miniature ballet. Saturn appears with a restrained majesty, its rings a thin hymn around a world of pale gold. No rush, no clamor, just orbits drawn with patient ink. Near the tops of the world, and near the bottoms too, the sky sometimes sings in color. Curtains ripple green and pink, as if the night has grown translucent wings, the aurora. Charged particles stream in from the sun and meet our air. Atoms glow, and the darkness becomes a living thing. You stand under it in winter, boots crunching, breath clouding, and you feel the quiet of cold. And above that quiet, a moving light that seems to breathe with you. There are places in the cosmos where matter thins, where entire superclusters give way to great, gentle voids. Imagine drifting through one of those vast clearings, where galaxies are rare and the dark is almost perfectly deep. Solitude there is not loneliness, it is spaciousness, the universe giving itself a wide, calm room. In such places you learn that emptiness too can be generous. Beneath everything hums a background, an ancient glow stretched into microwaves, the after warmth of a young cosmos cooling enough to let light slip free. It is everywhere at once, a faint blanket cast over all of space. Knowing it's there is like discovering that the house you're resting in has a heartbeat in the walls. A soft, steady reminder that everything began warm and bright, and has been unfolding, unhurried, ever since. Planets form the way rest arrives, bit by bit. Dust collects into pebbles, pebbles into rocks, rocks into bodies that sweep the path clean as they grow. Heat sparking, surfaces softening, atmospheres gathering like sighs. Millions of years pass without any need for hurry. And out of that patience come worlds, some icy and blue, some stormy and striped, some silent, stony, and ready to cradle a tiny lake or a future footstep. Gravity is the quiet law that keeps every promise. It tucks you into your mattress while it conducts galaxies in sweeping arcs. The same pull that sets tides and bends starlight is the soft insistence you feel when you choose to stay, to rest, to let thoughts settle like snow in a still globe. When you exhale, you can almost feel gravity smooth the air over you like a blanket. Remember too, the silence. Space carries no sound, no echo of flame, no rattle of stones, only the choreography of light and gravity and time. If you've ever stepped into a forest after snowfall and felt the whole world hush, the sky's silence is that, multiplied until even your worries feel embarrassed to speak. In that quiet, the mind does not need to be loud. It can simply note, I am here, I am safe, I am small, and that is peaceful. Out beyond, quasars blaze distant, powerful, and by the time their signals reach us, very gentle. Their energy has been spread thin across unthinkable distances, arriving as a faint, ancient murmur. Even the universe's most dramatic events soften with time and space, teaching us that intensity can fade into harmony. During the day, the stars are still above you, wrapped in blue. They do not leave. They wait. That constancy is a kindness. The sky is never truly empty, merely veiled. If you were to rise above the air itself, you'd see them again, steady and honest, even while the sun stands bright. What is hidden is not gone. What is quiet is not absent. The Milky Way and Andromeda drift toward each other, and in a few billion years they will overlap, swirl, and settle into a new shape. It will look dramatic if you could watch it sped up, but in real time, it is a slow waltz stars, mostly slipping past stars. Night after night, century after century, until a new, larger calm emerges. The universe is an artist who never hurries. Every stroke is patient. Between clusters, the dark grows cool close to the coldest temperature nature allows. Think of that not as harshness, but as a perfect stillness, a room kept for deep rest. In such quiet cold, heat is precious, and every small glow, every candle star, feels like a friend. Stars live and stars rest. Small red ones sip their fuel for ages. Big blue ones burn with brief, brilliant vigor. Sun-like stars one day puff gently, shedding their outer layers into glowing shells that hang like lanterns in the dark planetary nebulae, delicate and short-lived on cosmic scales. Brief artworks, exhaled by a life well spent. The cores cool to white dwarfs, embers that shine on in peace. From the ashes of heavier stars, new elements scatter iron for blood, oxygen for breath, carbon for softness and sweetness. We carry star stories in our cells. There is a mystery woven into the fabric of space, a pressure that urges everything to drift apart a little faster than gravity would prefer. Dark energy, we call it. A name that is really an open door. You don't need to solve it to be soothed by it. It is the universe's long, slow tide. Out, out, out. A promise that there is room to grow. For all of human history, we have looked up for direction. The North Star steadies our maps. Bright seasonal stars frame our harvests and our voyages. Even now, when satellites whisper us our coordinates, the sky remains a strong, simple compass. Look north, there is Polaris. Look east before dawn. The zodiac lifts another bright traveler. Guidance doesn't have to be loud to be true. Each observation we make, each sketch of a moon, each exposure of a distant cluster, each faint line in a spectrum is a page gently turned. The universe is a book with no last chapter, and somehow that is the most restful thought. You are not late to understanding. You are simply here for your part of the reading, and that is enough. Cosmic rays drift through all this, a fine, almost transparent rain of particles from faraway fireworks. They pass largely unnoticed, reminders that even in stillness there is a subtle exchange with the wider world. Quiet does not mean nothing is happening. Quiet can mean everything is happening without asking anything from you. Time, on these scales, is soft. It stretches, it flows, it forgives. Stars measure it in millions of years, galaxies in billions. When you hold your life against that canvas, worries shrink to manageable size. There is space to breathe. There is permission to rest. Lift your eyes once more and let them fill with starlight. See how the sky does not demand, it only offers. The longer you look, the more it gives faint clusters at the edge of vision, a dark lane you hadn't noticed, a slow satellite crossing like a moving punctuation mark. If your thoughts begin to wander, let them. If your breath slows, let it. If sleep approaches like a tide, welcome it. As you lie back under this wide, serene ceiling, remember, you are built from ancient light and cooled fire, from the dust of old suns and the water of wandering comets. The laws that hold galaxies together hold you together, gently and without fail. You are not separate from the night. You are a chapter of it. Let the darkness now be a cradle. Let gravity tuck the blankets. Let the moon stand guard at your window, and let the stars hum their silent melody, each one a distant lamp kept lit for you. There is nothing you must solve, nothing you must fix, nowhere else you need to be. The universe has been unfolding for eons without hurry, and tonight it invites you to practice the same grace. Breathe in and out. Feel the floor steady beneath you, the air cool on your skin, the quiet curve of your own pulse. With every gentle breath, the sky seems closer, as if leaning down to listen. Allow yourself to drift. The constellations will keep watch, the planets will move on their patient paths, and the river of the Milky Way will flow on, low and silver, until morning. Thank you for wandering with me across this calm, lantern-lit ocean. May your sleep be deep and unbroken, your dreams spacious and bright. Until we meet again beneath the quiet stars, keep looking up. Keep your heart open to wonder. And rest, knowing the universe holds you softly in its endless night.